Hi students, in this video, let's discuss when a system of equations with two variables has no solution, unique solution and infinite number of solutions. So that there are three cases over here. Alright, now we are only dealing with equations with two variables. For three variables, we would need a different concept called matrices to explain it, which is not required for this exam. So we stick to two variables to identify these three scenarios. Alright, let's proceed. And over here, I have the first scenario. Let's first take an example and we see an example for all the three cases and then we'll discuss the criteria. Now, if I have two equations that say x plus y is equal to 100 and 2x plus 2y is equal to 300, you can see that these two equations are inconsistent and hence they will have no solution. Now, what do I mean when I say that they are inconsistent? Over here, I have x plus y is equal to 100. Now, let me multiply it throughout with 2. So, I get 2x plus 2y is equal to 200, right? But over here, it's mentioned that 2x plus 2y is equal to 300. So, these two are not consistent. Therefore, there will be no solution for these two equations. Alright. Now, you can see that if I have these two parts, if you subtract it, you will get 0 is equal to 100. And which is also not true, right? And that's because these two are not consistent. Alright. Now, let's proceed to the second case. That is where you have a unique solution. We have two equations, x plus y is equal to 100 and 2x plus 3y is equal to 240. Alright. Now, let me multiply this throughout with 2. So, I get 2x plus 2y is equal to 200 and 2x plus 3y is equal to 240. Now, on subtracting, these two cancel out and over here I have minus y is equal to minus 40 or y is equal to 40. Now, I can substitute that over here and I will get x is equal to 100 minus 40, which is 60. So, you can see that there is a unique solution for this set of equations. Alright, let's proceed to the case where there are an infinite number of solutions. Alright, now let me have two equations, x plus y is equal to 100 and 2x plus 2y is equal to 200. Now, these two equations will have infinite number of solutions. What are some examples? You could have 1 and 99 or 20 and 80 or 55 and 45 or 50 and 50. All of these are equations for these two equations. Now, you can see that in fact, if you multiply this throughout with 2, you will get to this equation. So, that's why these two have infinite number of solutions. Alright, now let's keep this aside and check a criteria with which to identify whether two equations that are given have no solution, a unique solution or infinite number of solutions. Alright, now let me write a generic expression of two equations. So I have a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So you can see that I have used variables as the coefficients, right? Now let's analyze these two equations. If you have a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. In that case, there will be no solution for this set of equations. Now over here also you can see that you have 1 by 2, 1 by 2 and 1 by 3, right? So it's the same thing that's happening over here. So it's 1 by 2, 1 by 2 and minus 100 by minus 300 if you're taking it to this side as per this part, right? So that would be minus 100 and minus 300. This is 1 by 2, this is 1 by 2 and this will be 1 by 3. So the criteria over here is a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. Therefore, there will be no solution for this equation. Alright, what about the second thing where you have a unique solution? For that, you need a1 by a2 not equal to b1 by b2. And we don't care about c1 by c2. Alright, let's analyze it over here. a1 by a2 is 1 by 2 and b1 by b2 is 1 by 3. And these are not equal. Therefore, we have a unique solution for this system of equation. Alright, now what about the third criteria? If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then there will be infinite number of solutions. Let's analyze it over here. We have 1 by 2, 1 by 2 and minus 100 by minus 200, which is also 1 by 2. So it's satisfying this criteria over here and hence we have an infinite number of solutions.